All right, today we're diving into a really sophisticated attack on Linux systems, and it uses a vector you would probably never think of, the file name itself. So let's break down exactly how this is even possible.
I know, it sounds kind of crazy, right? I mean, how can a simple string of text, just a name for a file, actually become a weapon that can compromise a whole server? Well, that's the central question we're going to unravel right now.
You know, most of us in the tech world see Linux as this absolute fortress. It's stable, it's open, it's secure. But here's the thing. That exact trust we place in it, that's created a dangerous blind spot. And it's a blind spot that attackers are getting really clever at exploiting.
So the core of this attack, it isn't some typical software vulnerability, a bug in an application. No. Instead, the attackers have actually weaponized one of the most fundamental, basic parts of the entire operating system.
You know, when we think of malware, we usually expect it to be hidden inside a file. It's an executable or a macro in a Word doc, something you actually have to run. But in this case, that's not where the danger is. In fact, the file itself could be totally, completely empty.
And here it is, the big reveal. It's brilliant, and honestly, kind of terrifying. The malicious code, the actual payload, is encoded directly in the file name. The name of the file is the weapon.
So check a look at this. This is an actual malicious file name found in the wild. And yeah, it just looks like a jumbled mess of random characters, right? Well, that's completely by design. This isn't just a name, it's a whole multi-stage command, just sitting there waiting for the perfect moment to execute.
Okay, so how does this actually work? How does that string of text become a command? Well, the Linux shell is tricked into reading this file name not as just text, but as a series of instructions. First, that echo part outputs this long encoded string. Then, that string gets piped to base 64, which decodes it. And finally, the decoded text, which is now a clean, malicious command, gets piped directly to the bash shell to be executed. It's a whole chain reaction, hidden in plain sight.
But wait, how does this even get triggered in the first place? Well, the attack exploits something called indirect command execution. Basically, it just lies in wait for a really common admin script or a logging script to come along and simply read the file name. If that script doesn't properly clean up or sanitize the input, it gets tricked into executing that entire command hidden in the name.
Okay, so let's walk through the full anatomy of this attack chain. We're going to see how it goes from that one little file name trigger all the way to a full system compromise. Because this isn't just a one-shot trick, it's a really carefully planned multi-stage infection.
So the whole infection really boils down to 3 stages. First, that file name trigger we talked about, it gets executed and downloads a second stage script. Then that new script is smart. It checks the system's architecture, whether it's x64, ARM, whatever, and then it downloads the right binary to match. And finally, that binary decrypts the real payload, the VShell backdoor, directly into memory and runs it, all while disguised as a normal system process.
So, you might be wondering, where does this malicious file even come from? Well, the initial entry point is classic social engineering. It starts with a simple spam email, maybe disguised as a customer feedback survey, something that promises a small reward. Inside that email is a .rar archive. The user downloads it, extracts it, and just like that, the trap is set. And once that file is on the system, the trap just lies dormant, waiting for a script, like any one of these, to run. And look at these commands. These aren't obscure or rare. This is the kind of stuff you see every single day in backup scripts, logging scripts, you name it. Any one of them, if run in the directory with that malicious file, can kick off the entire attack.
All right, now let's get to the really clever stuff. Once the attack is triggered, the malware goes to some pretty extraordinary lengths to stay hidden. It's literally designed to be a ghost in the machine, operating totally silently and evading detection at every single turn.
This downloader script is just incredibly resilient. It's built to find the perfect payload for whatever system it's on, run completely silently in the background using no-hop, and it'll even try multiple different directories to make sure it can execute. And to top it all off, it sends all of its output straight into the black hole of /dev/null, so it leaves absolutely no tracks.
Okay, so the final payload is then fetched from the attacker's command and control server, but it doesn't come down in plain text. It's encrypted with a really simple XOR key. Now, this isn't super strong encryption, but it's just enough to scramble the file and make sure it can slip past any network scanners that are looking for signatures of known malware.
And this right here,
This is where the malware becomes a true ghost. The payload gets decrypted directly into the system's memory. It then uses a special system call called FXEVE to run it from there. And what this means is that the decrypted malicious binary is never written to the hard drive. It leaves zero evidence, zero footprints for forensic tools to find.
So, to complete its disguise, the malware does one more thing. It renames its own process to look like a totally legitimate Linux kernel worker threat, something like kworkers/0/2. Now, if you're a system admin and you're just glancing at a list of running processes, you would see that and think absolutely nothing of it. Meanwhile, there's a powerful backdoor running right under your nose.
So, after all that, what's the ultimate goal? What's the point of this whole elaborate attack chain? Well, it's all about installing one thing, a piece of malware known as the VShell backdoor.
And VShell? Well, it basically gives the attacker the keys to the kingdom. We're talking full reverse shell access, the ability to upload, download, and delete any file they want. They can manage processes. They can even use the machine to tunnel other malicious traffic. It is, in a word, total control. Okay, so let's pull back and really think about why this all matters. Why is this specific attack vector so important for us to understand? Because it really represents a fundamental shift in how attackers are thinking about breaching systems.
This technique is so dangerous for a few key reasons. First, it doesn't need any special permissions to get triggered. Its multi-architecture support means it can hit almost anything: servers, IoT devices, cloud containers, you name it. It's also highly evasive because it operates completely in memory and masquerades as a normal system process. But the real core danger? It exploits our trust. It turns the common everyday administration scripts that people rely on into weapons against themselves.
And that really brings us to the final and maybe most important thought. This whole attack, it forces us to reevaluate our most basic assumptions about security. I mean, if something as simple and seemingly harmless as a file name can be turned into a weapon, it really makes you wonder, right? What other safe parts of our systems are we all completely overlooking?